So we're standing at this point. The project used to be a creek that taking about 1/3 of the CBD Melbourne. We go straight into this creek underneath the freeway. And during the drought, there's not enough water to irrigate the park. So working with the council to convert what used to be a grassland into a wetland. So divert water from this creek and treat that water in this wetland. And then the clean water is stored in this pond, which is across the strip. The road will take you there. And this is called stage 1 of the project. So from that point, water is treated by UV disinfection and supply for the park. It was really successful. And then the government say, why you build a pond? Because when you build a pond, a lot of water harvest actually evaporate. And can you create more water for us? So the second phase is dig a hole in the grass and put a water tank as stage 2. So we'll show you in the outlet. You can see it's going both ways. Okay. So this is the project. So we're going to walk all the way up from the diversion point and follow the water path and see the entire water system, how that works. But I want to show you this, right? So you carry something in your mind when you look at the project. So this is Chiang Rai. I don't know whether you have been there, but this is the Kok River, and already created a dam there. So that's upstream, this downstream. And not far away before the dam is the irrigation canal that taking this water for the farmers. But this river is polluted from Myanmar. So you can think about maybe here or here, can we create something similar? Not exactly copy, but use a similar strategy to take this Kok River water and put it through the wetland. The wetland could look different because we are about removing the heavy metals, and then the clean water goes through this canal. So that's one of the ideas. So when we go through this project, in the back of your mind, you can think about how the strategy can be applied in Chiang Rai. Right? But of course, we need to create a new design for Thailand, but the strategy could be similar. Okay, let's go. Okay, so I'm taking everyone to the diversion point. So this is where the water has been diverted from this creek to the wetland. So from this point, from the weed level to the wetland, is about 2-meter drop. Okay, so everything has been done by gravity. Because it's online diversion, so this essentially is also a sedimentation basin. Right? Because we have a weir stop the water, and this part become a sediment basin. So that's why when we walk you to the wetland, you see no sediment basin, because this is the sediment basin. So there's a lower pipe take water to the wetland, and this whole weir is served as a high flow bypass. Right? So when the water coming out and when the flow is really high, it goes straight into this overflow weir and go to a deep pipe that connects to the downstream. Again, you see every sediment basin need to be designed with a ramp, so truck and digger can go in and dredge the sediment every 5 years, theoretically every 5 years, and ship it somewhere else. Unfortunately, we can't go in. Yeah, but you can see how that works. There's a flow. Can you hear the sound? You can hear the sound, right? The flow is being diverted, right? So let's go there and have a look. So this is the first process of the wetland, which is a sediment basin and the diversion high flow bypass weir in one place.
So currently it's a dry weather, so almost all the water getting into the wetland first.
Yeah, it's dry weather, but it's the base flow also go in, right? Because this is a large catchment.
Okay.
Yeah, even though it's not raining, all the basement of high sky buildings have a pump sump, because stormwater base water goes in the groundwater, right? So if you like this same thing as Bangkok, every basement of a high building have a pump, and that constantly pumping water out. That's why even there's no rain, there's always a base flow. from those buildings.
So underground water getting into the
Get into the car park,
yes.
and then that need to be pumped out. In Bangkok is even higher than this because your groundwater level is very high.
So the plan is man-made or not?
Yeah, this is a creek.
Man-
It's a creek, but
so
also
it's natural.
yeah, on the embankment is nature. Yeah. So I just want to explain this again, right? In Melbourne, the creek is the drainage system. So stormwater goes to the creek. The pipes we use only take water from the urban area to the creek. And from that point, it's the creek's job to take water all the way to the sea. And that is only for stormwater. Wastewater, we build pipe all the way from houses to the wastewater treatment plant. For stormwater, we only connect the houses to the creek, and that's it. Right?
So different from Thailand.
Yeah. Of course, in the past, right, the engineer trying to make the creek more efficient. We compromise the creek, right? But it's still a creek. Okay. Going that way. Any questions on this? I will be at 1.5.
ออกไปไหมเพราะว่าเพิ่งช่วงที่เขามา
The original design intent is for it to be a bird watch wall, right? But I don't think the bird is afraid of people. You can actually walk very close to them, right?
Yeah.
As you walk across the wetland, they just there. Selfie for Dr. Wow?
Yeah.
Have a selfie. So this is the starting point of the macrophyte zone. Is the actual wetland. So that's sedimentation basin and the diversion weir, and this is the starting point of the actual wetland. I think Flo asked me this question, right? When you have enough vertical drop between the diversion and the wetland, you can have a submergible inlet. People think that's nice, but in Singapore, people actually like to see the inlet. So that's a cultural difference. There's nothing wrong or right with this, right? If people don't like see the inlet, you just put a submergible pipe because there's enough height difference between the diversion and the actual wetland. In this case, it's about 2 meters. But in Singapore, when we design a project for them, they want you to showcase, expose the inlet so people see where the water come from. That's a two design concept.
Good photo.
Good photo. You look so tired.
Seating and 2 rows, right?
คืออยากรู้เลยว่า how deep อะ
ได้กลิ่นใช่กลิ่นแบบไม่ใช่เป็นกลิ่นโคลน
So there's a ring.
Yeah.
Yeah. So the base flow is not even enough to make to this point. Only can fill the first bed itself.
So only the rain can fill up this area.
And we need a decent rain, not even small rain.
So what's gonna happen if it's not raining at all?
I don't know. Some plants
Will
will
the
die.
plant die?
Yeah, some of the plant will die. I think if it's not raining for the next 2 weeks, maybe.
So
They are looking okay now, but if you keep going like this for more weeks, they probably will be in trouble.
do they plan to improve this area by pumping some water? in
No,
the
there's
future?
no water. It's the dry is not just in Melbourne, it's across the state dry. Everyone needs water.
อนเสิร์ตอีสานเขียว
So just let them die.
เขียวก่อนหน้านั้น
I mean, if when they have water, they have to make sure the sports field is irrigated first. So there's a priority. I think you asked me this question, right? So in the park, the Department of Parks, they have categories of the importance of the parkland, like a very important ones, and then goes all the way down. Right? If they have water, they have to make sure the very important parks are irrigated. That's where the water need to go, and then a worker will spray
ปี
down.
ที่แล้วมีเป็ดว่าวว่าวมีลูกว่าว
Yeah,
so
it was last year.
last year
Of course, that's in winter, right? This is that's in winter.
มีน้ำ
We should go to look at the pond. You see if the pond is dry, right?
เนี่ยเขามายืนส่องนกเนี่ยมาเปิดในหนังสือส่องนกตรงเนี้ย
Only in the mountain. In winter, you go up in the mountain. So we go skiing in winter. Yeah, but you have to drive 4 hours. Yeah. 2 weeks.
2 weeks.
No, separate. Yeah, now I can.
เกือบคนไทย
One thing I want to find out, want to learn is that if it dry like this, will the crack go all the way to the last layer, which is a compact clay, which is used to seal the wetland. So this wetland is not sealed by HDB liner; it's too expensive. It's sealed by compact clay. So those cracks, I don't know how far they go. Yeah. I will find out and let you know.
Yeah.
So I'm going to show you how dry it is. So this is the normal water level of the wetland. What we're seeing now is the actual water level is about 1 meter below the normal water level. So that shows us how dry this place has been. See, this is the normal water level here. So the wetland should be normally at this height. Right? And this is the extended tension. So that's the normal water level, this is the extended tension. Dr. Wall will know this, right? The current water level is a 1 meter below the normal water line. This is the weir level.
Okay.
The weir is normal water level of wetland.
Yes.
Now the water level is 1 meter below that.
Yeah. No what
Yeah, it has been dry for a long, long time.
but they still have some gate under there and when the water is not
Yeah, you can.
we
Those
can
gates,
open
You can open. We should feeding into this pond. Okay, this is storage pond. But in terms of design safety, you can see the pond has a very gentle slope. Even people accidentally walk into it, there's no cliff. They won't fall in. It's a gentle slope goes in. Well, half here, half here. And it looks like they have no water coming in for at least 5-6 weeks. Nothing coming in.
เนี่ยพีด้วย UV
อันเนี้ย
อันนี้อยู่
นี่ครับ
อันเนี้ยทิศแล้ว
นี่แหละครับนี่แหละครับเอามาตากแดด
From a design perspective, right? If the design we can design with a very gentle slope, but all planted, it is still okay. Look at that part, right? Because as water recedes in the middle, the plants come out. like this part is no good because there's no planting, but that part is a good design template. We were here last time talked about what we up to here. Up to here.
เยอะเชียว
Yeah.
ถ้าถึงตรงนี้ก็เยอะอยู่
You have a very good photographic skills. That's a professional. The water start overflowing, so directly into the creek.
Great
You can almost say this is like a rock swell. This is a swell, but filling with rocks. And that is the pump house. So this is the overflow from the pump during extreme flooding events. And this is the pump house, where the pump's UV disinfection unit, they're all stored here. So there's a pipe taking water from the pump, the pump, and going through the filtration and UV disinfection, then sent to the park. A purple pipe. That's the pump. So when this is designed, we're only pumping the water overnight because that's the electricity price is the cheapest. So there's a header tank on top of the hill. So overnight, treat the water and pump the water to the overhead tank. That is for about 2-day irrigation demand. And during the day, they use gravity to drive the irrigation nozzles. So to reduce the operational cost. Overnight, you fill up the tank, and during the day, you use the water from the tank. I introduced two very typical treatment systems. One is the horizontal wetland, the other one is the vertical barrier retention system. So this is the barrier retention system which you see here. So how this project works is, so when it rains, the water goes to quite a deep stormwater pipe. If we do nothing, all the stormwater goes to the bay. It becomes saline water, and also carry a lot of urban stormwater pollution into the bay. So this project basically pump that water from the stormwater pipe, put into the gross pollution trap, remove the rubbish, and settle the sediment, and then the water go to a large water tank, which is underneath this grass, which I'll show you. Okay. So the idea is that we're trying to capture as much as we can every time it rains. So fill this up. So it's only going through a very preliminary treatment, just remove the sediment and the gross pollutants. And then once it passes the rain, when we need water, then we take this water, pump it into this bulk retention system. So how much we pump depends on demand. Let's say we need 2 cubic liters a day for the next day. Then that's how much we pump. We don't pump more than that. And then the water going through this treatment to filter most of the fine particles, and then the water goes to the disinfection, UV, in that room. Okay, and then that water is going inject into the irrigation network of the park. Okay, so you have 2 tanks. So even though we show you these 2 tanks separately, but in construction it's constructed as one, only with a wall separating them. Okay, so it's one piece with a wall. Okay, so now I'm taking you to see where this tank is. You can see the system is running now. This is the wall separating the primary tank, which is the large one, under this entire grass. And this is the reuse tank. So water is pumped, harvested into this tank first. Sits there until the demand say, okay, I need some water, and then they pump this water to this system for treatment, and the treated water goes to here. And then from here, it goes to the UV inspection and pumped back to the park. So you can see, this is specially designed for people to come and have a look what's going on here. Right? Otherwise, we'll cover everything. No, this thing cut off. When people see here, people have to understand what's going on, and then people have to walk to that signage to have a look. That is the idea. You see, the water is coming from the barrel retention system from the base. Coming like this. And all the pump equipment here. The pump. This is the pump sump. From that point, it goes to that room, that shed. Yeah, you can still see water coming in filter. So the hydraulic connectivity of this system typically is about 120 millimeter per second, per hour. It's between 100 millimeter per hour to 200 millimeter per hour. So basically, it's sandy loam towards more sand. That way.
เส้นแบบปั๊มอยู่แล้วนี่คือ
As if they need, on demand. If I need it, I do it. But the idea is always trying to keep the primary tank full whenever it rains, so that you know you have water there if you want to use it. Yeah. But the treatment don't over treat. I only treat the amount that I'm going to use next day. It's about 1 meter deep, the filter meter, and then at the bottom is slotted pipe, a perforated pipe, PVC pipe with slots. Yeah. Collected, yeah. So the sandy loam, the soil, and the plant roots doing the water quality treatment, and then the clean water goes to the pipe, and then that pipe goes back here. So you will see, right? When they fill this up, they are full intake. 1, 2, 3, 4, or 5. They come in like a spring, like fountain. So water is pumping from a primary tank and then push out to distribute through the system. But again, right, the design is not perfect. I don't like it because the plant yeah, that's no choice because terrain. But the planting, they should do better. Right? They're lazy. They just use one species, right? Not beautiful, right? That is the problem. This is engineer. It's purely engineer, right?
No. So the engineer don't know about the plant. Inform enrollment because inform her.
treat by UV because it's water for irrigation.
Yeah, because it's a spray irrigation. Spray irrigation.
Spring. Spring.
Yeah, spray. Spray.
Or spray.
If it is subsurface, then you don't have to.
Okay.
You can spray, people can
Can be-
inhale.
okay.
Then you have to kill the bacteria. Yeah.
Irrigation
Subsurface, you don't have to.
spray.
Spray.
Where is the TPP cross
มีแผงอยู่มีปั๊มแล้วก็เป็นสายสีม่วงนะเดี๋ยวมันจะมีสายสีม่วง
Oh.
GPT, sedimentation chamber. So I create a virtual reality explanation of the project. I can send to you. So it's a VR.
นี้ GPT
GPT. Yeah, gross
So you
motor
can see
change.
the water coming out.
Oh.
Yeah.
It's pump.
Oh, perfect timing. You see everything.
โอเค
Oh,
นั่นคือปั๊มน้ำเข้ามา
ตรงนี้ใช้คำว่าฟิลเตอร์มันคือ
Oh, I should take it. You guys.
การฟิลเตอร์ตะกอนอีกรอบเบาๆก่อนแต่แล้วไอ้ต้นพวกนี้มันเกี่ยวไหมดูให้ดูพอดี
เหมือนดูดซับสารอะไรนะที่เขาของ ABS อ่ะ ใช่
แต่ว่ามันรีบแค่เนี้ย
ใช่อาจจะได้แค่นี้เห็นเขาว่าอย่างนั้นเขาก็แบบว่าแต่มันนิดเดียวใช่ไหมครับพี่
แต่ว่ามันคือการประดับตก ในรูปอ่ะมันคือเหมือนกับ
all the way to that point. That's the pointing depth is 200 millimeters. So theoretically, it only take maximum 2.5 hours to completely drill everything. So I create during COVID, I created a virtual reality platform using VR camera to feel this thing. I can send you a link so you can go into that using VR. Yeah. So there's a camera going to the pit pipes. You see how that's connected. By gravity into the second.